It's a very interesting NEET 2016 question on rotational dynamics. Problem is like this. From a disk of radius r of mass m, a circular hole of diameter r is cut from the center. What is the moment of inertia of the remaining part of disk about the remaining disk about the axis center of passing to the center, right? Here is an important point. Whose rim passes through the center is cut. So let me draw a diagram and tell you what is meant by it. So let's imagine a big circular disk. Moment of inertia of a circular disk about an axis passing to center perpendicular to the plane. Let me write that part first. Moment of inertia of disk about an axis perpendicular to the plane is mr square by 2, whose radius is equal to r. Now from this disk, a circular hole of diameter r whose rim passes to the center is cut. So what is removed is circular hole. Another disk part is removed, whose radius is equal to, whose diameter equal to r. Automatically, whose radius becomes half of that. For this removed part, circular disk is r by 2. So, what is the moment of inertia of the remaining part? Where is the remaining part? Here is the remaining part. Whatever I am shading, I want the moment of inertia of the remaining part. So, how do I get that? Moment of inertia of the remaining part is, it's very simple now. Moment of inertia of remaining disk is I total moment of inertia of the original disk minus I of removed part. Be careful about same axis. I total I already know mr square by 2. So if I have to solve the problem, I shall find out what is I of the removed part about the same axis. So what is the mass of the removed part? That's the first thing that I have to identify, right? So mass of a disk is how much? I have to find out. I can say density equal to mass by volume. Volume is area is thickness. Mass equal to density into area into thickness. 2 minutes revise. So being a disk, its thickness is constant, density is constant. So mass is directly proportional to area of cross section. Area is by r square. So mass is directly proportional to r square itself. That implies mass of a removed part is directly proportional to what is the radius removed is diameter is total r, so radius is r by 2. R by 2 whole square. That is r square by 4. Mass original is r square mr square. Mass removed is r square by 4. That implies I can say mass removed is m by 4. So mass remaining is 3m by 4. Similarly, radius of removed disk is r by 2. So now I need to know what is the moment of inertia of that removed part. I know what is its mass is. I know what is its radius is. I am talking about this part of the diagram. Whole mass is m by 4. Now, for that disk, I can calculate the moment of inertia about an axis passing through center perpendicular to plane. So moment of inertia of the removed part about an axis passing to center perpendicular to the plane. I of removed about an axis passing through center of that removed part is mr square by 2 is formula where m is m by 4 R is R by 2, mr square by 2. Moment of inertia formula is always where m is m by 2. Radius is R by 2. By 2 is there. So how much is that? M by 4, R square by 4 and 1 by 2. That is mr square by 4 and 4, 16. 16 2 is 32. But that's not the axis that we want. We want moment of inertia of that removed part about this axis. Because this is the axis about which the original disk is rotating. These two axes are parallel to each other. Distance between them is r by 2. So I can calculate I of removed part about axis of original. Using the parallel axis theorem, this becomes Ig for this removed part, who is mr square by 32. I want I for that removed part. I am only talking about this removed part all the time. So removed part about a original axis is Ig plus mass of removed part and distance between two axes, say x square. Ig we have already calculated as mr square by 32. Mass of the removed part is r by 4. Distance between the two parallel axes is r by 2 whole square. X is r by 2. So what is this value is mr square by 32 plus m by 4 and r square by 4. That is mr square by 32 plus mr square by 16. So LCM is 32 mr square plus 2 mr square. 3 mr square by 32. Right? That's the part of that moment of inertia of that removed part. Okay. Now I can calculate the moment of inertia of the remaining disk using this formula because I know the original moment of inertia and the moment of inertia of the removed part. Using both of them, that implies I of remaining is I original, that is mr square by 2 minus I removed 3 mr square by 32. So 32 is the LCM. This becomes 16 mr square, becomes minus 3 mr square. 16 minus 3 is 13 mr square by 32. And that's the answer for the problem. So looks like a little lengthy problem for you, but there's a lot of concepts involved. By learning this problem, you're actually learning the concepts. I want you to go through the problem again and understand that what I have done is I have calculated the moment of inertia of this removed part about an axis passing through center first of that removed part. Then I have calculated the moment of inertia about the original axis of the given problem using parallel axis theorem. Then I use this original formula itself. So go through the problem again, and if you have any doubts, just put a comment in the video section. Thanks for watching.